In this video, we'll talk about handling missing data in pandas. We've seen missing data before. When we added a series to another series and the index did not align, we got null values because these values cannot be calculated since the two series do not align. Null values, which are represented by NaN, are used to indicate missing values in pandas. Now, in Python, there are two ways to indicate a missing value. We can indicate a missing value using none, or we can indicate a missing value using a not a number value, which is a value associated with a double data type, and we can access it from NumPy by np.nan. When we create a pandas object, such as a series or a data frame, both these two values, not a number or none, are going to be treated as null values, and both will show as NaN in the series or data frame. That said, there are still some caveats here. Not a number is basically a number. Well, it's a numerical value that represent something which is not a number, but it means that from a programming perspective, you can combine it with any number using the operations plus, minus, and so on. None, on the other hand, is the null value of Python, and you can do anything with it. If you try to add or subtract, you're going to get an error. Now, those two different ways Python deals with none and NaN are not very important. Once the data is parsed into a pandas object, null values can be treated uniformly using some of the functions that pandas provide. Let's take a look at some of these functions. There is a function isNull, which basically creates a Boolean mask, masking the missing values, and notNull, which is the opposite of isNull. And then we've got very useful functions, dropNA, which will basically drop the null values from the data, and fillNA, which basically fills the null values with a certain value that we provide. These functions have some caveats that we will take a look at. Let's take a look at this example here. Once again, I'm constructing this series here, data, and this data has two null values in the second and the last position in the series. Data isNull is basically giving me a mask, and this mask will be true when the data is null, as the name implies. I can use my mask here to mask the data and get a subset of my data of my series which doesn't contain any null values. Now we can also, this is kind of a shortcut of dropping the null values from the series, and there is a certain function that does that for us called dropNA. If I do data.dropNA, I'm going to get the same. I'm going to get a new series in which the null values were dropped. Those functions are easy to understand on a series because, again, the series is unidimensional. They come a bit kind of more nuanced when we have a data frame. When we have a data frame that contains null values, we can take a look at the null values as null values on the rows or as null values on the columns. Thus, the function dropNA by default operates on the rows, so it's going to drop all rows that contain any null value. For instance, if you take a look at this data frame, you can see that the first row contains a null value, and the third row also contains a null value. Hence, both rows are dropped, and we end up with the second row, which is kept in the data frame. Well, there is an alternative here, which is dropping columns-wise. If I want to drop a column if the column contains a null value. So in this case, we use the same function dropNA, but we provide the axis argument to be either one or columns, indicating that we want to drop columns rather than dropping rows. Again, that's some of the default choices that pandas uses. Many often we drop observations rather than dropping variables, so that's why we usually drop the rows, we don't drop the columns. Okay, so the dropNA function drops whenever there is at least one null value. That may be very restrictive in some applications. Let's take a look at this example here. In this example, I created a third column in my data frame, and this column is all nulls. Hence, we have all nulls on this column 3. Now, if I drop NA and set my axis to be columns, it will drop a column if it contains at least one null value. Meaning in this case, I'm going to drop 0, 1, and 3, and I will end up only with one column that contains no null values at all. This may be kind of restrictive, and it means drop the column or the row if you're dropping row-wise if there is at least one null value. By default, that's the way it drops observations, columns, or rows, and that's called the how parameter. The default value is any. Another value that we can use is all, meaning only drop the column in this case, or the rows if this has been rows, if all of the values are nulls. And in this case, I drop only columns 3 because that's the only column that contains all null values. In between any and all, there is another parameter that we can use called threshold. And this parameter specifies the minimum number of null values to keep the row or the column. For instance, if you take a look at the data frame here, if I set the threshold to be 3, then it's only going to keep the row if there is at least 3 null values, which is row 1 in this case. If I set the threshold to be, well, this is 3, if I set it to be 2, it's going to keep actually all of the rows because all of them contains at least 2 non-null values. So this is a more nuanced way to control what to drop, either by setting the how parameter or by setting the threshold. The other alternative of dropping the null values is filling them. Instead of dropping null values from a series or data frame, we can fill them with special values. Let's take a look at this example here. Once again, we will start with a series, and in a series we have 2 null values. Fill NA will replace the null values with 0. So this NaN is now 0 and this NaN is 0. We've seen before using this function, many often we want to fill with a value which is not a 0. Maybe the average makes sense. So if you want to fill with the average, we can do fill NA and then take the series and calculate its mean. And this is going to fill with the average of non-null values, which is 1 plus 2 plus 3 over 3, which is 2. Okay, another way to fill in is to fill using previous values or next values. Filling with the previous values is called forward fill. It basically cascades the previous value to the null value. For instance, this null in B will be filled with 1 because that's the preceding value, and this null in D is going to be filled with 2 because that's the preceding value. The method backfill is doing the same except that it's filling backward, so this value in B will be filled with 2, the next value, and this value in D is going to be filled with 3 because that's the next value. Once again, once we have a data frame, we have 2 axes, so we need to specify what axis we are operating on in all of these methods when we use forward fill or backward fill. If we're filling with a special value, it doesn't make a difference here because it's just going to replace NA with any value. So if I want to replace with 0, that doesn't make any difference. Okay, so but if I'm doing forward fill, it's important to specify the axis because am I looking at the value before this value on the row axis or on the column axis? So in this case, when I specified my axis to be 1, if I'm looking at this null value, I'm looking at the column before, hence 1 will be cascading to this null value, and 2 will be cascading to this null value here, and 5 will be cascading to this null value here. However, this null value doesn't have any column preceding it, hence it remains a null value. Similarly, if I specify my axis to be the row axis to be 0, those null values in the first column, in the first row, will not be filled because there is no preceding row. This null value will not be filled because will be filled with NaN, so it remains a null value. This one remains a null value. The only one that will be filled is this one because there is a preceding value, which is 2 here. Lastly, I want to talk about a function which is not related specifically to the null values, but it's also a very useful function when we are replacing values in our data frame. And this function is simply called replace. If I want to replace, for instance, the value 5 with another value, let's say 7, I do replace 5 by 7 and I get that replaced. We can also use this one with null values. I can replace NaN, with 7, I get 7s instead of the null values. So it's possible to use the function replace. Fill NA is basically doing that for us. However, the function replace is useful because it replaces any value, not specifically null values.